In this video, we'll begin to investigate how Soundscape works under the hood and see how it works in the real world. In another video, I describe how the DS100 signal engine works as a system processor with full input-output processing and a powerful crosspoint matrix with crosspoint delay. Now we will look at some more advanced concepts which are made possible with an optional software add-on for the DS100 called EnScene. This upgrade is part of D&B's novel approach towards immersive audio, which allows the processor to intelligently distribute signals with varying level and varying delay to all available loudspeakers based on where a performer is located on stage. We'll start by looking at an application example investigating how EnScene can improve the behavior of our speaker system. This space will host many different types of events. Some of the use cases include high-profile speeches, where the audience will be seated across the entire venue. They also host symphonic concerts, where the audience may be seated around the orchestra. Or perhaps they have some interesting lecture positions, where a lectern is placed closer to the raked seating in the rear. And at Christmas, the entire floor may be filled with multiple orchestras and multiple choirs, making for a very wide performance area. Here we see a screenshot from R1, D&B's free control software. Each performer is represented by a sound object, an icon within the software which can be placed to represent the performer's location. Each object can be placed in a static position or moved to track the changing position of the performer. The processor can handle up to 64 objects at the same time, which allows for every performer to be represented individually. When the engineer places an object, the processor now knows the relationship between the performer and all loudspeakers in our system. The processor can now distribute the sound of that performer to every speaker with differing level and differing delay. This means every loudspeaker works to amplify every performer, but with individualized signal to best augment the performer's real-world location. Whereas our traditional systems exhibit unavoidable compromises. We're all familiar with the term sweet spot, used to describe the center area of the audience, where the sound of a stereo system is best experienced. The sweet spot is the only part of the audience which properly receives the stereo signal to experience proper localization, so that the lead vocalist in the center of the stage actually sounds like their voice is coming from them. And this part of the audience also experiences the most impact from the speakers, often referred to as a power alley effect. All audience members outside the sweet spot are listening to mono with a differing experience. But with EnScene, we're able to put the entire audience within the sweet spot. Now every audience member is having the same experience, which properly corresponds with your artistic intent. No matter which loudspeakers an audience member is listening to, they will perceive the performer's sound coming from the right direction. The impact of the system is also much more consistent from left to right, and we've allowed the mix engineer to achieve more clarity and depth without needing as much processing within the console. This type of approach is only made possible with delay processing, and is why Soundscape is the next step towards democracy for listeners. Back to our case study. When a high-profile speech happens, the engineer will simply place a sound object to represent where the microphone is located. The processor now handles all delay times for the first row of loudspeakers, as well as the second and the third. When the engineer is faced with a new mic position, they simply move the sound object and all delay times are recalculated. This allows the operator to be very flexible and very quick, and now with a more transparent sound system. And for the first time, the operator can easily achieve two use cases at the same time. The tuning time for the system was greatly reduced, and the operator is no longer reliant on predefined settings for various use cases. Because the delays are all handled automatically, we can do this without the need for hours or days of pink noise measurement. The system works as intended immediately after being powered on. Did I mention there's a 143-foot wide screen which won't allow for line arrays to be used because of sightline impact? Naturally, a distributed point source approach was needed. Luckily, with EnScene, every speaker is working as a coherent team, intentionally utilizing overlapping coverage patterns, and every speaker has a different mix of signals sent to it. This means the speaker can now perform louder, which allows us to use smaller speakers to achieve the same SPL as a traditional stereo system, except now with less visual impact. Here we can see the design within ArrayCalc, D&B's free prediction software. It allows us to evaluate the performance of the 64 speaker positions within the geometry of the venue. Notice how every speaker position and orientation is specified in great detail. Harnessing the existing positional data within the ArrayCalc file, the processor now automatically knows where every speaker is located. The processor also knows the speed of sound and how it's affected by changing temperature. Lastly, the operator has told the processor where each performer is located through the placement of sound objects. This allows for the first truly self-aware speaker system, which, in under 1.5 milliseconds, can automatically decide how to distribute levels and delay times. In another video, we will investigate the second software add-on, EnSpace. Imagine being able to selectively change the acoustics of your venue for some or all of the performers, all with the press of a button and without any programming time. More on Soundscape in another video. Thank you for watching. If you found this video helpful, please hit subscribe and feel free to reach out to us at support@dbaudio.com with any questions.